Alright, good morning. We are graphing quadratic inequalities with one variable today. So briefly, real quick, we want to go over the difference in an open circle and a closed circle. So an open circle is used when you have less than or greater than, not equal to. So open circle just shows the number that it's either going to be greater than or less than, but it can't actually equal that number. And you would also use parentheses in the case of an open circle or a less than or greater than sign. With closed circles, that's when you have less than or equal to, so the closed circle shows you can actually equal that number. So it's less than or equal to, or with greater than or equal to, you would use a closed circle or brackets, okay? So open circle, parentheses, closed circle, brackets. So the first example we're going to look at is x squared plus 3x minus 4 is greater than or equal to 0, okay? So what we're trying to figure out is when this portion on our graph is greater than or equal to 0, okay? 0 is in place of the f of x or the y. F of x and y mean the same thing, right? So we're looking at our y-axis to see when this is greater than or equal to 0 on our y-axis, right? So let's go to Desmos.com, and then we'll get to this part in 1 second. So let's look at Desmos real quick. Oh, and real quick, in Desmos, you're just going to type in this part, okay? Don't type in the inequality because it's going to give you some funky looking things. So just type in x squared plus 3x minus 1. All right, so we're in Desmos. We have graphed the x squared plus 3x minus 4. So here we are. The important thing that we want to look for, the main thing we're looking for on our graph, is to see our solutions, right? So solutions is just another word here for your x-intercepts. So we have an x-intercept here at negative 4, 0. And we also have an x-intercept at 1, 0, okay? So that means negative 4 and 1 are our solutions to this quadratic function, okay? Now we want to take those solutions and use those to help us figure out where our inequality is true, okay? Where on our function, this red function, is it greater than or equal to 0 on our y-axis, right? So here's your 0. Everything greater than that line, right, is going to be part of our solution set for inequality. All right, so I've transferred Desmos graph onto the paper so I can illustrate on the paper what I'm explaining to you guys. All right, so we want to see where this is greater than or equal to 0 on our y-axis, right? So here's 0 on my y-axis. Oh, this didn't work. Okay, here's 0 on my y. So basically, anything above this line, right, our x-axis, is going to be greater than 0 on our y, right? Anything above this, 1, 2, any of these points, right? So the 0 included, right, this point, 1 on our x, 0 on our y. This point's included because we have the or equal to, okay? So this point and everything above is part of our solution, and then nothing in between because this part of our graph is below 0. And then this point and everything above is also greater than 0, okay? So I want to find a way to write all of these values, okay? So what we're going to do is we're going to write a range of numbers, okay? So this is going to keep going and going all the way, it's going to the left, so it's going to keep going all the way to negative infinity. And then this one's going to keep going all the way to the right to positive infinity, okay? So, and then here we had negative 4, 0. So what we're going to do is we're going to say any values on the x-axis from negative infinity to negative 4 would all be greater than 0, right? And then any numbers on the x-axis from 1 to infinity would all be greater than 0. Anything in between, like if I chose 0 on my x-axis, that's down here below our line, right? So that one wouldn't work. So we're gonna say our answer ranges from negative infinity. Infinities always get parentheses because you can never actually equal infinity. Infinity just keeps going. So if we go from negative infinity to -4, and since we have the or equal to part, we put a bracket, okay? But then that's not all. It also, so to show that what it also does, you put a U for union, kind of like you're combining this with this. Going from 1, it can equal 1, so we put a bracket, all the way up to infinity, and infinity gets parentheses. So this would be our answer. If you chose any value on your x-axis between negative infinity to -4, it's greater than that line, right, than 0. And then also, if you choose any number from 1 to infinity, it would work. So another way you can kind of think about this is looking at it on a number line, okay? So we have a closed circle at -4 and a closed circle at 1, right? So it's kind of turning this into a flat number line. So what you could do is you could pick a number between each section to see which one works, right? So if I chose any number between -4 and 1, let's say I went with 0, I would plug in a 0 here and see if this turned out to be a number greater than or equal to 0. If it did, then I would want to shade this part, right? But if we did this correctly, then we should be shading these parts, right? The -4 to negative infinity, and then the 1 to infinity. So let's see. If I took x squared plus 3x minus 4, and I plugged in a 0, 0 squared plus 3 times 0 minus 4. Well, 0 squared is 0, 3 times 0 is 0. Is -4 greater than or equal to 0? No. So we would not want to shade this part. Okay, let's pick a number greater than 1. Let's just say we picked 2. 2 is a number greater than 1. So we're going to plug in a 2 here. So, let's see. Yeah, y'all can still see that. So I would have 2 squared plus 3 times 2 minus 4 is greater than or equal to 0. 2 squared is 4. 3 times 2 is 6. So 4 plus 6 is 10, minus 4 is 6. Is 6 greater than or equal to 0? Yes, so we would shade this, okay? And the same is going to work if we picked a number here, -5, -10, whatever you want to pick. Okay, so you would shade there. And then from this you can see we would have the same answer. Our shaded sections go from negative infinity to -4. And then it also, union, goes from 1 to infinity. All right, so we're always going to start out by graphing this part into Desmos so that we could look at it, okay? So y'all are going to want to type that in Desmos. So you guys would want to graph this section into Desmos and look at it, okay? It's easier so that I can draw on it to show you better if I draw it out on the paper, okay? So you should be graphing this into Desmos, and then you can look and see what your solutions are, because those are going to help you figure out how to write your range of answers, right? So we're looking for where this part is less than 0. Okay, well, here's our 0 line. Here's where y is 0. Before we wanted everything greater than, now we want everything less than, okay? Well, less than doesn't end up going to infinity. It is a limited amount of answers. It just goes from one solution to the other. Since it's less than or not less than or equal to, it's not going to actually include those points, okay? So this was at 2, 0, and then -4, 0, okay? So we want to give an answer that states this range of numbers from -4 on my x-axis over to 2 on my x-axis, and everything in between, okay? But it can't include -4 or 2 because they're not equal to. So for this, we're just gonna say -4 with a parentheses to 2 with a parentheses. And that is your answer. All right, so one more example. If we had x squared minus x minus 6, you would obviously want to graph this in desmos.com. I've drawn it out for us already so we can look at it. We want to know when this is greater than 0. So here's our 0 line, right? Here's everything where y is 0. And we want to know which parts of this function are greater than that line, or greater than 0. Not equal to, so we can't include our solutions. We can't include these numbers. Just everything greater than, right? Okay, so once again, our shaded parts are split up, right? It's this section and this section. They don't go together, okay? So we're gonna have to union them. So we're gonna say from -infinity, you always go from smallest to largest. So the smallest it's gonna go would be all the way to -infinity. And then we're gonna go to -2. Since we don't have an equal to, right, we are going to put a parentheses. So I'm gonna put open circles around these and not shade them in to show that it's just everything greater. So we're going from -infinity to -2. And then we combine that, so I just put a U for union, from 3 to infinity. Okay, and this would be your answer. Okay, for this last example, I want to show you some special cases. You're not going to see these often, but you could run into them one day. So this is where your function looks like this, okay? It is right on the line, right? So you have 1 point touching your x-axis, and if I gave you 2x minus 3 squared needed to be less than 0. Just less than, not equal to. Here's my line. Is there any part of my graph that is less than this line or lower than this line? No. So you would just say no solution. There isn't anything that's less than that line, so there is no solution. Or vice versa, if you had something that said 2x minus 3 squared is greater than or equal to 0. Okay, well here's 0. Here's everything that's greater than or equal to 0. That's everything, right? So it would be all real numbers.